Here's an application problem of a trig function. Given a scenario, create a graph and a model, an equation, so you could use it as a model and then plug in some values. So this is problem number 1, and I'll read it to you. As you ride a Ferris wheel, your distance from the ground varies with time. So here you are on this Ferris wheel, this thing goes around, and your distance over time. So it's going to be time is my x-axis, distance my y-axis. I have to be in radians because my time is going to be seconds. Okay, I find that it takes me 3 seconds to reach the top at 43 feet. So that gives me 1.43 feet in 3 seconds. So now I have one value or 1 point on my graph. I'm 43 feet above the ground. The wheel makes a revolution every 8 seconds. And the diameter of the wheel is 40 feet. So the diameter of the wheel is 40 feet. And I make a revolution every 8 seconds. So I'm at the top of this Ferris wheel right here, 3 seconds. 8 seconds pass and I'm back up here. So that means 8 seconds later, this distance here is 8 seconds. 8 seconds later, I'm back at the top. So at 3 seconds I'm here, 11 seconds I'm here, and my low point right here will be halfway between the two. So if this distance is 8, this distance is 4, so plus 4 plus 4, and the diameter is 40 feet of this wheel, so the lowest I'll ever be is 3 feet. My quarter point here will be at 5, plus 2 plus 2, plus 2, plus 2. So my quarter point is at 5 and at 9, and it's halfway between 3 and 43. That total distance is 40. Half of that is 20. So 3 plus 20, 23 plus 20. So now I have my graph. And then from this graph, I'm able to create an equation. I need a roadmap, y equals c plus a cosine b x minus d. Now I have to fill in these pieces. Y equals vertical shift, 23, plus 20, how far I go up. It's a cosine graph. I'm going to leave b blank for a second. And then x minus 3, where I start. So to figure this b value out, I know I got to create an equation. 2 pi divided by b is equal to my period of 8. So I cross multiply. 8b equals 2 pi. Divide both sides by 8. And I can see that b is 2 pi over 8, which reduces to pi over 4. That's my b value. So now I have a scenario. From my scenario, I create a graph. And then from my graph, I create an equation. And this is a powerful tool because now with this equation, I could use it as a model to make predictions. So it says, what is the lowest you go as the Ferris wheel turns? The lowest I go is 3 feet. Write an equation. Turn the page here. Predict your height above the ground when t equals 6. So this is saying when this value is 6, how high am I? So to do that, first thing I do with my calculator is I make sure I'm in radian mode. So I got my TI here. I don't know if you'll be able to see this, but I'm going to go to mode, over to radian. Easy to forget that. And then I'm going to go 6 minus 3 equals times pi equals divided by 4 equals. And now I'm going to take the cosine of that value. So I say cosine of my answer. I hit equals times 20 plus 23, and I get 8.86. So let's see if that even makes sense. When x is 6, my corresponding value is 8.86. Yeah, I would have expected actually 6. Yeah, that looks right. Okay? And then the other kind of question they could ask you is if y is a certain value, like if I am 18 feet above the ground, what time would that happen as? So I'm plugging 18 in here for y. Don't forget that is a dependent variable that I'm plugging in, so I'm going to have an infinite series of solutions. Okay, so let's do that on my calculator. This I do a little bit differently because now I'm really trying to isolate the x here. So I take 18 and I plug it in for y. So on my calculator I'm going to go in radian mode, 18 minus 23 equals divided by 20 equals, I have to take the inverse cosine of that answer divided by the quantity pi over 4, and then I'm going to add 3, and I get 5.3. So when y is 18, I get 5.3, getting a little crowded here. So that's 5.3. This value right here, the way I find this value is I create this line of symmetry over 7, and I could see this is 1.7 units away. So this value is 1.7 units away. So my next value is 8.7. So I got 5.3 from my calculator from plugging 18 in for y, going backwards solving for x, which means isolating that variable x. That gave me 5.3 seconds. I could see it is 1.7 units from 7. Therefore, it's symmetrical over this line. This value is 1.7 beyond 7. Don't forget this graph goes on forever in both directions. So if I want to find this third value is going to be one period beyond this. So one cycle beyond this is the period's 8. So 5.3 plus 8 is 13.3. So my first three positive values for x when y is 18 is 5.3, 8.7, and 13.3. Okay.